So again, the questions that I have is, and the opportunity is what decisions do you have that might need to be made 1,000 times a day? And then the further follow on to that is that you might use ML to solve problems which you're currently writing rules today. The classic way of getting insights is we develop a rule set, we develop some code, and then that will produce some sort of insight or some sort of answer to our question. And with ML, we're able to flip that around. So we provide the answers, we provide what's currently happening, and we provide the code, and then that turns it around into the rule set. And so where are you currently writing rules today? Areas where we write rules are, operations. So there's lots of heuristics in an oil and gas facility, for instance. And those heuristics drive when things shut down, when things turn on, what pressures are allowed, all those types of things. And so, the oil and gas industry is actually very, very heavy into writing rules and writing heuristics for controlling control systems. And so the question is can we use ML to, instead of taking those rules just the way that they are, turn them around into the actual insights? I have an appendix at the end that sort of explains that concept a little bit differently, but you can go after that. So yeah, great. We can save 50% or 40% energy in a system, even on the world's most efficient systems. But the reality is that we actually have to engage with these old school industrial established systems. We have to work with the existing data and the existing hardware and the existing infrastructure. And that's a key insight here in that, we can't just apply machine learning to anything. And we have to actually thoughtfully think about what it looks like to actually do that. The approaches that we have to decision making tend to be experience. So we rely on people with lots of experience. We rely on things like dashboards, or we rely on things like automation and digital twins, so these hard-coded heuristics and rule-based decisions. And so as a result, these tend to all be human-derived things, meaning there's a human in the middle of it making the end decision or implementing the end decision. And with AI, again, we get that opportunity to create repeated, scalable decisions that can happen hundreds of times a second in a way that a human just couldn't handle. And so our big challenges in this space are not necessarily the amount of data that we have. We've got lots of data, but potentially how it's structured, and then the talent to be able to work on that data. Open source is sort of a concept that runs through many, many different industries now today. But ultimately, in this space, we do have a challenge with data and talent. I know Hossein will talk a little bit about the talent that we do have and how we can leverage that. But think about the data sets that you have and how do we get those out and start to use them more effectively. The data sets that we do have tend to be siloed away. And so I usually get to this, less than 5% of the assets that we have are connected to the internet. They might be connected to each other, but they're not necessarily connected to the internet. And there's obviously issues with that. So security is a big important thing, but key thing is less than 5% of them are connected to the internet. And then of the data that we actually do pull out, of that 5%, 97% of it's never used again. And so you can imagine oil and gas companies essentially taking a lot of data, distilling it down to a very small bit of data, and then using even a smaller bit of data to make the decisions that we make every day. And what would happen if we could use, all of the data rather than just a very, very, very small subset of it? And that paradigm sort of creates silos. And so we see silos of data all throughout the companies that we work with. And again, this isn't just in oil and gas, it's in a lot of other industries as well. So we have assets that are connected to the internet that becomes its own silo of data. We have document-based data, we have image-based data, which are their own silos, and until we can unlock those. Enterprise applications become their own silos. They tend to not work really well together. And then we have networked assets that, due to the need for safety, they are siloed off from the world. The data only comes out in the form of a report at the end of the month, potentially. So what's next? I'm going to leave this one, and I think we can maybe pick it up because I'm sure people ask it. But I'll leave that one and turn it over to Hossein. And yeah, we'll go from there.
Hello, everyone. My name is Hossein, and I'm with Alberta Machine Intelligence Institute. A little bit about me. I got my PhD from University of Alberta in process control. And since then, I joined Amii as a machine learning advisor. And I help my clients from different domains, but mainly in oil and gas, to build their own capacity in AI, and also trying to help them to work on the project that they have in their pipeline. And I just give you a quick overview about Amii as well on this slide. As you can see, Amii is a nonprofit organization based in Edmonton, and we have mainly three mandates. We advance leading edge research in AI ML by funding academic research and empowering industry leaders to invest in Alberta's world-leading talent and expertise. Secondly, we grow business capacity and capabilities in AI and ML for startup, SMEs, and enterprise clients to support their growth, improve operation, and solve complex problems. And third, we build Alberta's AI ML workforce by funding research positions to teach the next generation of professions, and also by developing and delivering educational materials for technical teams, managers, and executives to upskill their team. So these are the three main mandates that we have at Amii. I'm going to talk about something that I want to be the messenger of bad news first, and give your attention to a couple of statistics that we have. So on the top right corner, you can see some sort of statistics that you can go to this site, CS ranking, and basically you have all these different areas in AI and ML and different areas in computer science. And if you just check the artificial intelligence and machine learning, and here you can play with the years of that you are interested in. And we want to see all the publication and citation, for example, from 1970 to 2020. And if you just look at that, you can see the UFA is number 4 in the whole world, which is amazing. But that's a great news, and if you just want to focus on that. But on the second one, if you just look at the last 10 years, from 2010 to 2020, we can see we are going a bit lower. Now we are number 6. And if you just look at the last 5 years, you can see UFA is number 30. Still, this ranking is great, but overall, our performance is not improving. It's actually inverse. And this is something that I really want to talk about and say that we shouldn't just think about the current situation that we have. It's a very competitive world. There are different companies and different countries who are investing $1 billion in this domain. And if you want to be the first one, or be the one that actually drives the engine in this case, we are losing that. And that's at the global scales. The second way that we are losing this game is the nationwide. If you look at all these 3 figures, you cannot see any other universities in Canada right now. But when it comes to investment of big companies like Facebook, Google, Amazon, their first choice is not Edmonton or Alberta. They usually want to build their headquarters around Vancouver, Toronto, or Montreal. And that's the other game that we are losing. And I just want to bring your attention to these 2 big factors that we should be aware of. So now let's talk about the good news that we have. The first one, as I said, University of Alberta is well known in the field of computer science, AI and ML. So on the right-hand side, on the bottom plot, that you can see all the talents that are existed across the globe. And after US and UK, Canada is number 3. And this plot is mainly based on number of LinkedIn profiles and also presenters at different conference related. So overall, Canada is doing good, but we should still doing better if you just look at the 3 previous plots that I showed you. The second thing that I want to mention is that, of course, we have a hard time to compete with Vancouver or Toronto to bring and attract big companies, but it doesn't mean that we haven't done it. There are actually companies who actually build their own lab in Edmonton. The biggest one is DeepMind, which is owned by Google actually. And they're just here mainly for 3 profs that we have at UFA, working on reinforcement learning. We also have Borealis from RBC, we have IBM and Volkswagen who have brought their own labs here, which are good news. The other piece that I want to talk is about what kind of industries can we focus on in Alberta that make us unique. When I think about it, there are 4. The first one is oil and gas. As Greg mentioned, they are very data-driven. They have so many data that they have collected so far. The second one is health. And it's a very interesting case for Alberta because the way that we collect data and with all the regulations that we have in health, the data set that we have in health is somehow unique in the whole North America. And we collect way more data, and the data is way more comprehensive compared to other provinces or countries. And talking about COVID, which is a big topic these days, Amii has been involved with 3 initiatives these days trying to help different people trying to make better decision making right now with COVID situation. The other 2 industries that I think would be really good candidates are agriculture and constructions, because they are very popular in our province, and I think we have a very good history of data in this domain. And also the other piece that is very important with running AI and ML is the domain experience that you have. Since we have been doing these industries for so long, we have so many talents in this domain that have the experience to help those technical people who are going to develop the ML or AI model with giving them some insight. And the other opportunity that we can talk about is the 4th bullet, that we don't even have to just focus on the industries that we have. As we have a good pool of talent here for AI, we can build a new industry called AI industry that we can focus on. And the other piece that I would like to touch base on is about the tech ecosystem that we have in Alberta. There are way more than you think, or more than 100 startups, companies focusing on AI in Alberta. And there are so many things going on in this province, mainly like about the meetups, lunch and learn session. In Edmonton, we have a Startup Edmonton, which organizes so many good events. And if you want to step in this field and learn more about what's going on, these are the good events that you can attend and learn more about. And the last one is that AI and ML is just, to me, is a tool that you can use to make better decision making, like the plot that Greg showed. This can be just another additives to your decision making to help you to make your decision better. And this is nothing more than that. And you should just realize how you can use these tools in your own domain. I can talk about 2 cases studies very quickly that we have done at Amii. The first one is about trends prediction. Right now, as again Greg mentioned, they're mainly based on operators' experience, and we are doing well in this case when we can visualize our data simply in Excel, and it's like 2 or 3D dimensions, and if we can visualize them with little few variables, we are doing great. But what if we need to make the trends prediction when we have like 100 sensors around one equipment? Are we still able to do the same kind of prediction? I highly doubt that. For example, if you have a reactor temperature and the y-axis, and we want to predict the temperature for the following time, what kind of features, what kind of sensors we can use to improve our prediction? Because human overall is very good with trending, and if you just look at the existing history of data, you're just gonna go with the trend, and you might ignore the context that you are at. And that's where machine learning can be helpful. And we have done a project like this for predictive trends for sensors in pipeline and help operators to make better decisions. The second one is very close to what Greg mentioned about the Google data house optimization. Again, when you have a process, you are really good in making decision making when the number of variables are small. You can visualize your problems, and you're really rely on the operator's experience. But if you have way more decision and variables, that's the time that you might not be able to do your best. And in this case, machine learning can be helpful. And in the case that I'm talking about is actually a combination of machine learning with mathematical optimization, which has 4 steps. The first one, when you want to do the mathematical optimization, you need a mathematical model that can mimic your system. It can be based on physics, or it can be based on empirical. The physical one is when you just go back to your textbooks, like mass transfer, heat transfer, or all the physical engineering facts that we know to develop a model that can replicate our system. But the second option is not just going with your models, going with the data that you have from history of the system that you have. And in that case, you develop a model that can represent your system based on the data that you have collected so far. And that's the piece that machine learning can play. And after that, you need to, in the second step, you need to define an objective that you have, whether you want to maximize profit, whether you want to minimize costs or power consumption, or what is the objective that you have. And the third step is using another tools, which is mathematical optimization. And when you run that mathematical optimization, and the fourth step, it spits out the decision variables for you. And we have done it with two clients, one in pipeline operation, and the second one is for desalination plants. And for both of them, the objective was minimizing the operating costs. And with the first one, we want to recommend the best configuration of pumps on a pipeline, like whether they should turn the pump A or pump B, or when they're turning them on, what should be the set point for the discharge pressure, something like that. I think that has been my presentation. Back to you, Pong.